Hello everyone, welcome to MathsTuber. Today we are going to start with the topic trigonometry, which is the chapter number 8 of NCRT. So the word trigonometry can be divided into three parts: tri, gono, and metry. Tri means three, gon means sides, and metry means to measure. So the branch of mathematics that deals with the uh, sides and angles of a triangle, because three-sided figure is the triangle only, so that is known as trigonometry, right? So it is the branch of mathematics that deals with the sides and angles of a triangle, and specifically in 10th class we are going to deal with a right angle triangle. So first of all we have to learn about a right angle triangle here. So suppose this is a right angle triangle here, and suppose this is the angle which we have taken as theta, right? So let us say this is A, B, and C, and this angle B is of 90 degree here. This is 90 degree. So we all know that uh, the side opposite to this vertex 90 degree is known as hypotenuse, which is denoted by capital H, and hypotenuse is the longest side of a right angle triangle. Then the side opposite to this angle theta is known as the perpendicular, which is denoted by capital P, and the remaining side is known as base, which is denoted by capital B, right? So you just have to remember that the side opposite to the angle that you have taken is the perpendicular, because hypotenuse will remain the same. The position of perpendicular and base changes according to the angle that you have taken, right? Now, because a triangle has three sides, so there can be six ratios in it, right? So a right triangle have three sides. One is hypotenuse, perpendicular, and base. So therefore, there can be six ratios which are P by H, B by H, P by B, and the other three are the reciprocals of these, that is H upon P, H upon B, and B upon P. So these are the six ratios. Three are here, P by H, B by H, and P by B, and other three are the reciprocals of these. And these six ratios are given the names like sine, cos, tan, cosec, sec, and cot. So we have to just see that what are the names of these ratios and what are the formulas. So let's talk about trigonometric ratios now. Trigonometric ratios. So the first is sine, second is cosine, third is tangent, fourth is cosecant, fifth is secant, and sixth is cotangent. Now, sine, short form of sine is sin, sine, and cosine can be written as cos, tangent can be written as tan, cosecant can be written as cosec, secant can be written as sec, and cotangent can be written as cot. And we have to place theta in front of all of these trigonometric ratios. But sine and theta or cos or theta are not in multiplication. Sine is the representation of the trigonometric ratio, and theta decides which side will be the perpendicular and which will be the base, right? So they are not in multiplication to each other, they are dependent on each other. So P by H, this is B by H, this is, so we have given the name of perpendicular upon hypotenuse as sine, base upon hypotenuse as cosine, right? Similarly, perpendicular upon base is tangent, and other three are the reciprocals of the first three. So it cosec theta will be h upon p, sec theta will be h upon b, and cot theta will be b upon p. So the easy way to learn this is by forming this table where you can learn. So you can learn a line like Pandit Badri Prasad, Har Har Bhole, and Sona Chandi Tole. So Sona Chandi Tole is SCT, which represents sine, cos, and tan. So we know that the formula of sine is P upon H, cos is B upon H, and T is P upon B, right? And other three are the reciprocals. So here you can write cosec, sec, and cot. So cosec is H upon P, sec is H upon B, and cot is B upon P. So the line is, I am writing it here, Pandit Badri Prasad Har Har Bhole Sona Chandi Tole, right? So this is the line by which you can learn these ratios here. Then after that, there is one note here which is very important. It says that the values of trigonometric ratios of an angle do not vary with the length of the sides, right? The values of trigonometric ratios of a certain angle do not vary with the length of the sides if the angle remains the same. So it means that suppose you are having a triangle and suppose you are going to increase its all the length, but you are not increasing or decreasing its angle. This angle you are not increasing or decreasing. Suppose the starting triangle was this, and now you have increased its length of sides, so the height will also increase. Similarly, if you keep on increasing the two sides here, the other side will also keep on increasing. But if the angle remains the same, then the trigonometric ratio will remain the same, right? So based on this, let us come to an example where you are given with, suppose tan A is given as 1 upon root 2. Suppose this is the value given, and you have to find the other trigonometric ratios, which means you have to find sin A, cos A, sec A, cosec A, and cot A. So you have to find other trigonometric ratios, right? So what do we have to do for this is, you just have to write down the value which is given to you, and you have to compare it with its formula. So the formula of tan A is perpendicular upon base. So if we draw a small right angle triangle here and take this angle as A, and this is theta, so the perpendicular becomes opposite to this A, and both of these will be multiplied by K. So it will become K upon root 2K. So perpendicular will become K, and this will base will become root 2K. Right now, why do we have to multiply both the ratios with K? Because the ratio is always in the simplest form, and we don't know what is the common factor of these two numbers in the numerator and denominator. And because we don't know that common factor, so we have to multiply both numerator and denominator by K, and K act as a common factor here. So now you have two sides of the triangle. So by using Pythagoras theorem, you can find out the third side of this triangle ABC. So using Pythagoras theorem, you will get AC square is equal to AB square plus BC square, which is equal to root 2K square plus K square, which is equal to 2K square plus K square, which is equal to 3K square. So AC will be equal to under root 3K, which means that the value of hypotenuse is under root 3K. Now we have to find out the values of other trigonometric ratios according to the formulas. So sin A is always perpendicular upon hypotenuse, which we know. So perpendicular is given K, and this is given root 3K. K will cancel out each other, and you will get the value as 1 upon root 3, right? Similarly, if we want to find out cos A here, which is base upon hypotenuse, base is given root 2K upon root 3K is the hypotenuse. K will cancel out each other. You will get root 2 upon root 3. Tan A is already given, so we will find out cosec A. Cosec A is h upon P, which is root 3K upon K. So this will be root 3 only. K will cancel out each other. Similarly, sec A will be h upon B, which is root 3K upon root 2K. K will cancel out each other, so the answer will be root 3 upon root 2. And lastly, cot A will be equal to B upon P. Base is given root 2K upon perpendicular is K, so the answer will be root 2. K will cancel out each other. So this is how you have to go for the question where you are given with a ratio, with one ratio, and you have to find the other trigonometric ratios. So now let's come to the question from exercise number 8.1 of NCRT. Exercise 8.1, where question number 3rd is there, where you are given with sine A equal to 3 upon 4 and you have to find out the value of cos A and tan A. Right. So what we have to do is you have to just first multiply both numerator and denominator by k and compare them with the formula of sine A, which is p upon h, perpendicular upon hypotenuse. Now, if we draw a small right angle triangle here and take this angle as A, this is B, and this is C. So according to this angle A, perpendicular will be BC. So it will be 3K, and the hypotenuse is AC, which is 4K. So now we have to find the base using Pythagoras theorem. So using Pythagoras theorem, AC square is equal to AB square plus BC square. So that will be 4K square plus, sorry, equal to AB square plus 3K square. That is 16K square minus 9K square is equal to AB square. So AB square will be equal to 7K square and AB will be equal to under root 7K. So you have got the value of base as root 7K. Now we have to find the value of cos A, which is base upon hypotenuse. So base is root 7 upon K, sorry, root 7K, and the hypotenuse is 4K. So K will cancel out each other and the answer will be root 7 upon 4. Similarly, we can find out the value of tan A, which is perpendicular upon base. Perpendicular is given 3K and the base is given root 7K. So therefore its value will be 3 upon root 7, right? And suppose if someone asked you that you have to find the value of sine C. So if you are taking this C angle as your angle, so in that case, the line, the side opposite to the angle C will become the perpendicular, which means that AB will become the perpendicular and BC will become the base now, and AC will remain the hypotenuse. So we know that the formula of sine C is perpendicular upon hypotenuse, which is root 7K divided by 4K. So the answer will be root 7 upon 4. Similarly, cos C we can find out base upon hypotenuse, and the value of base is 3K and hypotenuse is 4K. So the answer will be 3 upon 4 here. Similarly, you can find out the other trigonometric ratios using the angles, right? Now, let's come to the next question, where we are given with the sides of the triangle. So this is the question number 1 of NCRT, where you are given with a triangle ABC right angled at B. So this is a right angle triangle which is right angled at B. Let us say this is A and C here. So you are given with AB is equal to 24 centimeter, BC is equal to 7 centimeter. And we have to determine the values of sine A cos A and sine Z cos C in the two parts. So if you are given with the complete length of the sides, then you don't have to take K. right? So using Pythagoras theorem, first of all, we have to find out the third side, which is the hypotenuse here. So AC square is equal to AB square plus BC square, which is equal to 24 square plus 7 square, which is equal to 576 plus 49. So AC square is equal to 625, and the value of AC will come out to be 25 centimeter. So this value is 25 centimeter here. Now in the first part, we have to find out the value of sine A and cos A. According to the angle A, perpendicular becomes 7 centimeter and base becomes 24 centimeter. So sine A will be perpendicular upon hypotenuse, that is 7 upon 25. And cos A is base upon hypotenuse, which is 24 upon 25. Similarly, in the second part, we have to find out sin C and cos C. So according to the angle C, perpendicular upon hypotenuse becomes 24 upon 25, and cos C is base upon hypotenuse. So according to the angle C, base becomes 7 centimeter and hypotenuse is 25 centimeter. So this is how we have to solve the questions where the sides of the triangles are given. So you don't have to multiply k with the sides if the sides are given to you, right? So this is the part 1 of trigonometry. In the next part, we are going to discuss more questions of exercise 8.1. Thank you.